So we're going to start the final panel. Sorry, we had to get mic'd up, switched out. So I'd like to invite Wanda Lau to moderate this last session. Wanda Lau is an award-winning editor and writer who oversees tech practice and product coverage at Architect magazine. She is also a host and producer for Architects podcast. Along with a decade of experience in the AE profession, she holds a BS in Civil Engineering from Michigan State University, an MS in Building Technology from the Massachusetts Institute of Technology, and an MA in Journalism from Syracuse University. So she will be moderating our this last panel. It seems like a very quick day, even though it was a very full day, and looking forward to the conversation.
Hi, everyone. Thank you. I'm so honored to moderate this panel of distinguished experts with such a range of backgrounds. And this is the very best time slot of the day, so thank you, Tien. I know this panel is the last thing between you guys and the exhibition or wherever your plans might take you this Friday night, so I will keep my eye on the clock and have you guys out of here by 6. So I attend a lot of conferences in my line of work, and it's very rare to find something so interdisciplinary that actually has experts across the AEC spectrum, and especially having practitioners present side by side by researchers. That's a really unusual thing, so please embrace it while you're here at the University of Michigan. And since you're likely familiar with the keynote speakers already, and also some of the faculty and staff who are here at University of Michigan, I will just give a very brief introduction to each of the speakers. And you can obviously see their full credits in the programming bio. And then this is going to be a very high-level talk about research. And I'll try to leave 10 minutes at the end of this for questions from the audience. So please think about things you want to ask some of these our distinguished guests. So Mark Burry is an architect, and he is the founding director of the Smart City Research Institute at Swinburne University in Australia, where he's also a professor of urban futures. Sarah Billington is the professor of civil and environmental engineering at Stanford University, and also senior fellow at the Woods Institute for the Environment. And obviously, both Mark and Sarah gave excellent keynote presentations yesterday and this afternoon. Jonathan Massey is the dean and a professor of architecture here at the University of Michigan, which you probably all know. And he's also a renowned scholar of modern architecture. Renowned. Jerry Lynch is department chair of the Civil and Environmental Engineering program here, and he's also a professor, and he also holds a courtesy appointment as a professor in the as a professor of electrical engineering and computer science. So again, more of that interdisciplinary studies is very admirable here. And then Vol Kursik is the director of the Global CO2 initiative here at the University of Michigan. And this initiative focuses on the technologies, resources, and policies to increase the rate at which CO2 is removed from the global carbon cycle. So thank you very much.
Do you mind if I ask them to come forward? I'm going to make one request. We're in the home stretch here. I think this panel will be energized and inspired if some of you at the back are willing to move up toward the front so that we can have more of a engaged conversation with you all. Thank you.
Well taken, but they all know that I'm a chemist and are afraid that I might run experiments. So
yes.
I understand your fear, but come closer.
I request a renowned architect. Thank you.
Build protective walls.
Thank you. Thank you for that prompt, Jonathan. Obviously, you can see he's also an excellent educator, too. Quick question for the audience. How many of you guys are undergraduate students? Most of you guys, one? Oh, great. And graduate students or postdocs? Excellent. OK. I know that sometimes it can seem impressive, the backgrounds and accomplishments of these presenters, so I want to start my questions with just a quick introduction to each panelist about how they found their way to a career that involves research, and if there was a single moment or interaction at which they decided to stay on the course of being actively involved in research, starting with Mark.
I didn't become an academic until my 30s. I had 8 years of practice first And I hit what I call the plateau. And the plateau is where you realize you have insufficient charisma to ever see yourself leading a practice of 400 people, or you just don't have the entrepreneurial zeal, or in my case, you just realize that where you could go in practice was not going to happen in practice. I'd been contaminated with my experience at the Sagrada Familia, and I just realized after 8 years of diligent service that I wasn't going to get what I wanted, and that change would have to come through an academic injection. So that was my, my epiphany.
Yeah, so I was not ever planning to be an academic. I went to grad school thinking I would go into design, and then I got a fellowship to get a PhD, and I was like, okay. And then as I was finishing, I still thought I would go into design, and someone asked me to apply for a job at Cornell, and I applied, and I got it. So I was like, well, that's a pretty good job. And so I really kind of fell into it, but I kind of knew that I would like the teaching, but I really wasn't sure about the research. But I'm very thankful that I did, and I think, did you ask what led to different trajectories? Or?
Yeah, yes, so was there a singular moment or interaction that led you to keep staying
Yeah,
in the course
I
of
think
research?
what kept me in academics was I got to go abroad early on in my career, and I went to a conference actually, and I heard Victor Lee, is he still here? Yeah, give a talk about ECC, and I was like, that's a really cool material, and it just inspired me, and I realized it could mix with some of the things I was trying to do, and it just helped give me kind of a research direction, and so I did that for a while, and then, I mean, it turns out that academics has been really good for me, both for just the flexibility of the career, and then also just being able to move into other areas of interest, because I definitely, as you could see from my talk today, I have very different interests, and I think that would be, I mean, it's hard enough to do it in academics. I think that it would be even harder, I think, in industry, just to try to pop over to something new. So I'm really thankful that I went into academics.
Wanda, I think you will hear that frequently, that none of us probably has planned this, right? It all just happens. I was interested in chemistry and physics, so I went to university really scared, because I learned that A, I needed to get a PhD to really do something in this field, and B, to get a PhD, I needed to do something that nobody has ever done before, and that I just couldn't even imagine. But once you're on that path and you sort of discover that there are so many unanswered questions, as Sarah said, I mean, you go from one thing to another. I started in chemistry, moved into mechanical engineering, now I work in the medical school and other things. So there's always an inspiration that keeps you going, and the more I thought about what gets me up in the morning is what makes a difference? What kind of big questions can we answer? What do we need to do to really make sure that us as humans and the planet as a whole can continue to prosper? And lately I find myself intrigued with the question of we seem to be rediscovering what we have done for thousands of years, right? In looking at we all used to be universalists. Of course, we now know so much that we have to specialize and therefore learn how to work together was what in the past we have done as individuals. And therefore, at the university, we can choose how to collaborate with who and in what form. And I think that keeps us going with research.
Yeah, so from my own experiences, it's really about being able to push boundaries. And when I was an undergraduate and then later I worked in industry before going to grad school, I worked for a big design firm in New York City, and I could see that those that had PhDs really had opportunities to sort of expand what those boundaries were in their professional practice. And that was my motivator for doing graduate school. During my graduate years, I could see that by not necessarily going to industry, but kind of going to academia as a professor, again, you could continue to push those boundaries. Those boundaries are further and further away. So it really is buying you a lot of freedom for the creative process, for basically tackling very complex problems and really having impact as a scholar in solving those problems. But it's really about having that intellectual freedom, creative freedom, and not having boundary conditions that I perceived to had existed when I was working in industry. So for me, that was my motivator.
I think my own path is a little bit similar to what Jerry just described, in the sense that as an undergraduate, I was so invigorated by the intellectual ferment around the humanities in architecture. Remember, it was the high decon moment, and post-structuralism was pervasive, and the architects that were most compelling in school were totally disconnected from the market. They were making artworks for display in galleries, and they were making conceptual projects that didn't, at the time, Zaha Hadid, we were talking about Zaha Hadid in this room a week ago, proved that there are pathways to major production out of that moment. But it just seemed to me that market-driven architectural practice was not going to engage me in those big humanistic questions. And so I went into architectural history and theory and found that I didn't quite find the impact there. I mean, it's a fairly niche world. And so that search for impact has brought me into academic leadership, in realizing that if I can support the kind of amazing work that presenters today have shared and that our students and faculty do, if I can support that and tee them up for success, then my little efforts will actually have some of the impact that I haven't found a path toward doing architectural history scholarship.
Wonderful. And many of you are probably on the cusp of your next step in either your career or continuing your studies in academia. Would you recommend that a budding architect or engineer enter practice in a conventional setting these days, or would go into research? And if so, what kind of context of research, such as like a public setting or private sector, or a combination of these? Several of you have practice experience, and so what would you recommend for the audience?
Well, I used to get into trouble. We have something in Australia called Open Day, where it's meant to be the high school kids come and see whether they want to come and do architecture or not, but they often these days have their parents in tow. And the parents would say, here's Johnny, he's always wanted to be an architect ever since he was 2. And I say, well, you've come to the right place. They say, but the only thing is, I've heard that the salaries aren't so good. And I'd do this kind of, what? Oh, really? I didn't know that. Oh, is that important? Well, I'm thinking, and I'd say, well, and they'd say, well, it's 5 years. I say, yes, but philosophy, chemistry, building science, economics, social science, history, it's all there. And after 5 years, if all else fails, well, you can always be an architect. And apparently that wasn't the right message, but I honestly believe that's how it is. You come to do all these things, and you may decide that a conventional practice is what you want to do, but hopefully you'll see other opportunities. And so I've had 3 economic cycles now where you've got graduates coming out and almost certain not to get any jobs. That's what happens when you get older. You can sort of reflect on this. So from a very early stage, I've always felt that our primary responsibility is to make sure that entrepreneurship is high on the agenda. So even if you go into a practice, you'll go in there with some real sort of drive.
Yeah, I don't think I could ever tell anyone to do one or the other. For sure, I think it'll have to come from your gut, like what you feel is going to be meaningful and where you want to be. As Volker said about that meaningfulness, I think that really is important. We have a D school, design school at Stanford, and they have a course called Design Your Professional Life. And I send all my graduate students there. And it's so nice because they go and they choose sort of 3 careers they're kind of thinking about, and they find someone in them and they go sort of shadow them for a day. And there are a lot of other things that they do in that. But I think it's really important to see what's out there and explore. I know I kind of just fell into things, and I'm glad in the end, but I do kind of wish that I had explored earlier and other things. So I think, just to try to find what's meaningful. And then also there's that point, like if it doesn't work out in one, you can go to another. It's really, you're not tracked. I've seen so many people change. That's definitely possible.
Yeah, I think that's a really good point. That we're not sort of pigeonhole us if we make a decision at some point in our life. But I don't know if I can really answer this. I mean, I've been in school now for 51 years, never had a job, so can't certainly speak from experience. But my experience as a teacher, as an educator, certainly is you need to talk with the students. You really need to sort of explore what are they good at, what they're interested in. And we're lucky to play a game of numbers, right? It's not that we need to be worried about advising half of our class on this and half of our class on that. It all will work out. And I strongly believe that we are only doing our best if we enjoy what we're doing. So teasing it out sometimes takes hours. Just the other week, I had a student in office hours, and we spent another hour just to explore, does she really understand what are her own desires and what does she think others expect from her? I think I see that a lot, and you need to help students to go beyond that and take it from there.
Yeah, and I would just reiterate, I think it's really about articulating to students, sort of empowering them to follow their heart and to really sort of not consider these other considerations that students often think about, which may be salaries, schedules, things like that, but really find the thing you're going to be passionate about, the thing you're going to really enjoy, and the thing that won't really be work. And if that's in the research arena, great. If it's in the professional practice arena, great. But it's really just about finding your inner self and what's going to make you happy as a professional. So.
I mean, right now I'm most excited about the places where those things come together. And we've seen a lot of that today, where practice or industry-based work, experimenters are connecting with academic researchers and helping one another do things that neither one can do by themselves. So that for me is the sweet spot. And at Taubman College, we're focusing quite a bit on the chance to think about what that looks like for the urban tech, for the intersection of data and technology-based entrepreneurship with buildings and cities, which I think is one of the hottest areas, like this one that we've covered today.
I think sometimes there's a tendency to get so focused in on your work that's due in the near future that you forget to look up and take advantage of all the disciplines that are available to explore here, especially in a university setting. So that's something I wish I had done more when I was in graduate study, just to explore and learn more things. The role of concrete and cement production embodied in the carbon emissions in the world has come up today throughout several people's talks. But at the same time, concrete does make up a significant portion of our built environment, both the foundation and the building blocks. Were there any research directions that were talked about here or that you see in your own line of work that you find promising in terms of mitigating the impact of concrete and cement in carbon emissions? And I mean, Volkers, this is especially something you're probably focusing on a lot, but I'm sure everyone else here has touched upon it in their line of work.
Sure, and I mean, of course, there are always multiple avenues in how we can be more mindful in how we use materials and how much. We heard just in the last panel that sometimes codes that might no longer apply because we have new materials need to be revised so we can go about making the same thing with half the material. That's one thing, but I think also we need to learn to really explore new materials and be more strategic about how we develop those. And I think you have heard this afternoon about new ways and how concrete can actually be made in a more environmentally friendly manner, all the way starting from cement making to how the concrete is being put together, mixed and cured. I found this one of the intriguing conversations this morning in the first talk, right? That I mean, of course, CO2 attacks concrete, but in the afternoon you heard that you can actually make concrete with CO2 and thereby lock this up. And this finds its entry into everyday products. This watch is made with concrete that has incorporated carbon dioxide. So I think the versatility, as far as I understand, of the material will not make us want to stop using it. So we just have to be smarter in how we make it and how we use it. And I think here you've heard a lot of those kind of concepts in how to make this happen.
So maybe I shouldn't really admit this, but I'm going to admit it. When I learned about the CO2 emissions, I was really shocked, and I started to get interested in sustainable materials, and I kind of jumped ship. And I guess partly because I wasn't really necessarily good at the cement chemistry, or that wasn't my area, but I was really interested in composites, and that's how I became interested in the bio-based composites. And I still saw that as contributing to construction. Something like 40% of our landfill volume of construction, well, 40% of landfill volume is construction and demolition debris, and of that, 40% is like wood and plastics that takes a long time, even wood does, to biodegrade. So I got into these bio-based composites. So, so I guess the point is that there's lots of different materials that we can look at for the construction industry. Yeah, I'm really excited about all of the new developments in concrete with the CO2 especially. It's really cool.
And I was sort of struck actually with the first talk. They gave the 100-year perspective. And I think what that teaches you is that when we come together as a community and we look at how to evolve a material, it's amazing what we can do. And looking at concrete and its narrative over 100 years, how much we've advanced that material and the uses that we see it in today, that capacity still exists. So even if concrete isn't necessarily the material we select in the future, just seeing the promise that's held within a community coming together over that period of time and innovating on a material, I think holds great promise for new materials, whether it's bio-based composites or others. So I think we should keep that in mind as well. What is our capacity to change the future in terms of different types of materials and what their attributes are, and how we evolve those materials to be more sustainable, more resilient, easier to work with, what have you. So
I think another dimension of that historical perspective, piggybacking on what Jerry just said, is something that I really respond to, Brandon, in your work, which is the thinking about time in radically different scales. And I know in some of your other work that I think is informing the stuff we're going to get crushed by later tonight. I know part of what you're thinking about is the lifespan of buildings, and how can the Cyclopean masonry teach us to think about building for hundreds of years or thousands of years, as well as for 50 and 100-year lifespans. And I think that's a really compelling part of the equation from today's work.
One thing, well, the first talk this morning was a jolt, mostly because it reminded me of something I read in the newspaper. It was either New York Times or Guardian, possibly this year, about most of Northern Europe and North American infrastructure is reaching the end of its life. Concrete, that's tunnels and bridges. When I read this, I thought, how can this be true? Because it's not being discussed. And I spoke to a few people and said, oh, yes, it is a bit of a problem. But that's all I've ever heard about it until this morning. Is this an elephant that is in the room that we aren't addressing, that we are focusing on all the great things we will do with cement and concrete in the future, but do we genuinely have a legacy of buildings that are going to come to the end? I live in a recycled factory that was built in 1929 in the centre of Melbourne out of concrete. It's one of Australia's sort of early reinforced concrete buildings.
How carbonated is it?
Well, I mean, it meant that I was distracted for the rest of the day, just worrying about this.
Sell now.
Mark, in your smart cities research, do you talk about materials like the inclusion of, say, timber? Like I look at Google's Quayside community in Toronto, where they're trying to emphasize the use of timber a lot. Is that something? Do you see the hybrid use of materials?
Yes. I run something called the Smart Cities Research Institute, and the first thing I said when I arrived is that I don't even know what a smart city is. But it turns out it's kind of like a generic term that nobody really knows what it means, but it kind of covers it all. So our institute goes across the whole of a technical university, because the thing about cities is that everybody's got some skin in the game. So the simple answer to your question is yes, of course. We are very interested in knowing how sustainability will be visited on cities by making better use of what we already have in place and adding things which are not going to be disastrous from a climate and resources point of view. But we're genuinely concerned. I live in the city of Melbourne. It's coming up to 5 million, and it will be 8 million by 2050. It's the fastest growing city in the developed world, little known fact. It's got huge implications. It's growing so fast that we're not able to do things we need to do to take hold of the future. So we're going laterally. It now takes an hour to get from the center of Melbourne to the periphery, even when there's no traffic, which is not very often. And so we've got this, this kind of, it's kind of like a cancer of suburbs with no work. So it means more and more car journeys. And we've got these extraordinary tower blocks, 50 stories plus, for very poorly planned apartments. And the medium density, which Barcelona does so well, is just not on our lexicon. So I think with materials, medium density is going to be the answer because it does give us a much wider range. Tall buildings of 50 stories plus sort of tell us that we've got a very narrow range. And obviously the excrescence of the suburbs, we're just using very cheap materials, building what we call Mac mansions. I don't know if it's a term here, but
It is.
yeah.
Very interesting. And in transitioning and scaling research and innovations from lab to site for this topic, what transactions and interactions do you see needing improvement? I know Ken Hover mentioned earlier this morning the very visceral statement that we're not building buildings out of manure because it's more expensive than cement and concrete. So obviously first cost is a big hurdle in bringing some of these innovations to scale. In your experiences, what can we be doing better to bring these experiments, such as some biomaterials, from lab scale to actual industry scale?
I can address that really fast because I was meant to say it earlier too, is that with the bio-based, it was a lot of fun and we get properties similar to wood and get these insulating foams, but it's way too expensive for the construction industry. So it's kind of demoralizing. But in the end, a couple of the students that were working on it have a startup and they're growing plastic next to a wastewater treatment plant and they're producing different kinds of products and they're working out kinks to try to make it more scalable and large scale. So it's still fun to see. I think it'll be a while before it's in construction and it would only be temporary or maybe residential because there's the fire issue, But it was, but yeah, that's been fun to see. Maybe it has to go somewhere else first before it goes into construction, but you can get it to scale or go to the site. Yeah, but I was going to say, I think on the concrete side, my experience was just that there are a few very innovative contractors around that really like doing something new, and when you can find them to partner with, then I've seen things be pretty successful. But there aren't very many, and I guess I would ask Ken about it, because I know that what they have to do is they have to use that provision that's like, or you can do whatever you want if you prove it's going to be okay. There's always that provision in the code. And I get, you have to find a building official, is my understanding, that's willing to use that part of the code. I don't know how common it is, but that's what I've seen lead to innovation.
But that's a real issue. If you say what's the biggest impediment, I think we're not able to innovate fast enough because there's not easy pathways to put things out into practice and then essentially assess, iterate, and then use that as a key part of your innovation cycle. And I really think that is one of the biggest impediments, whether it's cost or it's being conservative, trying to be compliant with codes, things like that. I think we need to figure that out. It's certainly something that I think you had asked before about encouraging maybe students going towards research. This is one of the things that really dampens enthusiasm. When you look at other industries, like the high-tech industry, where their ability to put things out in practice, succeed or fail rapidly, iterate, it speeds up that whole process of innovation. And our process right now is pretty slow. I think it's pretty conservative. I think for very good reasons. Ken raised very good points this morning. But I think we need to work harder as a community, figuring out ways, how do we accelerate that? How do we create opportunities for innovators to be innovative and show impact? Because right now it's much too slow. I think a lot of technologies are out there, but we don't really ever get chances to test them at scale. And that really detracts from our abilities to really embrace these technologies and move them to a point of real adoption. So,
on the educational front, I think we're tackling it two ways. One is by, I've been pushing a lot this emphasis on prototyping and getting ourselves, architects are the original iterative designers. And this is such a key facet of software innovation, right, or tech innovation, things like the urban prototyping practices that New York and San Francisco have used to redesign their streetscapes. I've been really challenging planners and architects here to focus on paths toward deployment, and that prototyping not just making a single version of something to win a prize and show it in a gallery, which is good. Our faculty need to keep doing that. But also then what do you learn from the successes and failures of that, and how do you iterate on it toward deployment and toward market? So I've been focusing quite a bit on that. And one of the most exciting things I see some of our faculty doing is learning from tech transfer processes how to recognize, protect, and potentially commercialize intellectual property in and around architecture, so that we start to teach ourselves and our students how an idea might find its path to deployment and to market in ways that are different from conventional architectural practice, which is what I think we're used to prioritizing in our education.
Right, and if I can add to this, I mean, we heard about the impediments that are existing out when it comes to regulations and barriers because of that, but also internally as educators, I think we need to look at this differently, starting with the students and how we educate them, but also with faculty. For example, in the Global CO2 Initiative, we only fund work if the participating teams have an interest or at least a willingness to engage in translational research. That is, with a purpose to put it into action. I mean, hardware-based solutions often take decades to show up in the marketplace. That's too long. And part of it is not just regulations and building codes, but also our own internal value system. And is it the gallery or the journal paper over the patent as one thing, but also, amazingly enough, things happen in a linear fashion. So what we do is, from day one, ideally, if we capture a researcher having an idea, there is somebody from tech transfer working with that person. Even if you have no interest in commercializing, we find a person to help you with it, so you don't have to deal with it. We put psychologists together with engineers to help them understand that you have the greatest product in the world, but nobody will use it, and here is why. Right? So it needs to all be looked at in a synergistic way to not lose time, so that after the fact we discover, ooh, we should have taken a different approach to developing a product or approach. So it needs all of that to make that happen quickly.
I was thinking about some of Sarah's research, how you kind of transferred from structures research to human wellness and productivity. I think that knowledge about social sciences is interesting and speaks to a large part of some of the benefits of being in the academies, that you can kind of spread your wings and see what else is out there. What kind of resources do you recommend people look into if they have multivariable interests?
Oh. Well, I feel really fortunate. I think Stanford has a lot of sort of small pockets of seed money for these kind of interdisciplinary grants, so that really helped, of course, to get people to work together. And then I think it's been mentioned before just about collaborations, like you have to, I think Anya mentioned it, that you have to find the right people. And it's not that there's only one set, it's just the right ones for you. So I've been in some collaborations where it's just right off the bat, we'll argue and butt heads, and it's fine, and we can move on and work together. And others where I just can't even understand what they're saying. I just can't speak the same language, no matter how hard I try. And I had prided myself in getting people to work together, but then this one group I got together, I was like, this is not working, And so that one just kind of fizzled out, but then other ones succeeded. So I think, yeah, it's finding people that you can gel with that have a similar sort of passion or interest.
Right, and in order to make that happen, you need to sort of reduce the barriers so that people can start to work together, even though they don't know each other, they don't necessarily have things lined up where there's a natural confluence. Here at the University of Michigan, we have a program called M-Cubed, where every professor receives a $20,000 token. And then if we find two others in other schools or colleges, we form a cube, and we have $60,000 to spend. There is no review for contents. I mean, there's review for human subjects research, if that applies. But other than that, that's how we found a lot of new teams that now brought their expertise together because they weren't constrained by having to wait for funding and all that. And a lot of interesting things happened this way.
In fact, some of the stuff that was presented today was a direct benefit of MQ, Victor's work, Brian, Vineet, robotics, Lego construction.
The Catalyst program at Stanford was actually inspired by things like MQ. I remember looking at it, yeah.
So that's brilliant. I can tell you what doesn't work is when you have a program like that, but then the sting is you've got to get matching funding from outside business, because that's the situation we're in. And it's such a pity, because I think we would have much better chance if we just got on with the work ourselves. In Australia, we definitely need to be incentivized. We can't just put a good idea out and expect people to come out of their silos. But that sounds great, to be able to do that without having any strings attached to it.
Mark, you mentioned briefly the headache of finding funding, which is a big problem, a big part of the academy. Has the climate changed? And I've talked with a couple other practitioners or researchers here about the climate of finding funding in a government that's less interested in maybe funding basic research these days. What changes have you noticed in the climate for research-based funding?
Well, I can speak for Australia, which isn't the States. We look at the States with wonder at the just sheer generosity of the philanthropic foundations. My understanding is that government funding is not really the only source, but philanthropic. In Australia, we have very little philanthropic funding. And the Australian Research Council, which I've been a great beneficiary of, is highly competitive. In architecture, about 6% of our grants get up. So one has a lot of very bright colleagues putting year in, year out grants. But just coming back to the earlier point, which is research needing to be quicker, it seems to me we've got a problem with, in the Western world, with political cycles that don't value thinking, well, maybe we need to be putting things in place for 20 years' time. Australia, it's about the political cycle is 3 years, and you can imagine what that's like. And then the other great problem is the market. And for some reason, and certainly in Australia, the market should lead outcomes. But of course, the market won't. It'll only force us to do the things that will make a profit now, not later. So it's quite a bleak scenario, I think. So the only positive thing about climate change is that at some point the penny is going to drop, that serious investment's required, and that these grand challenges are such that it's not going to be an infrastructure engineer or a planner or an architect or a social scientist who's going to solve this. It's going to be a team of really good people, and that's why I think the sooner the universities find mechanisms to encourage us to work together as faculty, then we will give students a good model to follow.
The way we have attacked that problem is looking at carbon dioxide as a resource to make products, including concrete and other materials or substances. And that makes the effort more agnostic. So even if somebody doesn't believe that climate change A exists and B work into it should be funded, we can still talk to, because we are actually making products that people need. We are creating a new economy, and we're creating economic wealth. So I think as researchers, we've always been challenged in sort of how do we best package what we want to do. A good example was that years ago, funding for soot research disappeared, but nanoparticulate research was all the hype. Well, guess what? Soot particles are nanoparticles. So you see some of that, but I think my experience in 30 years of fundraising for my research is it's always been difficult. And yeah, there are peaks and ebbs, but still, it's always a struggle. We spend 40% of our time, even if we're not dean, in administering our research program, and that is quite a number. So Monday and Tuesday we come to work to do paperwork.
Looking back at your own careers, either in academy or industry, is there a field that you wish you would have studied more besides your engineering architecture, such as law or writing or humanities or business even, that you think would be useful now for either getting grants or doing thought leadership?
So our colleague in the College of Literature, Science, and the Arts, Lisa Nakamura, who's leading the creation of a Digital Studies Institute, likes to say that gaming is the storytelling medium of the 21st century. And I'm sad that I spent so much time studying as a youth instead of becoming a gamer, because I feel radically disadvantaged today.
There's a lot of psychology. There's lots of things involved with that in gaming.
My favorite classes as an undergraduate actually were my senior year. I took Russian literature and religions in American society. And so I do wish, even though I did have a lot of humanities, I wish that I had had more of that. And I had the opportunity, I was lucky, I got to choose the 3 books that all the freshmen at Stanford had to read over the summer this past year, and then I interviewed 2 of the authors of the books on stage, and one of them was a novel called There by Tommy Orange, who's a Native American but urban, and it took place in Oakland, so that was near Stanford, so that's why I chose it. And I asked him at the end of the interview on stage in front of all the freshman class, I said, could you speak, like you're in the humanities or the arts, and the other person also had majored in English, and I said, could you speak to the importance of the arts? Because everyone at Stanford wants to do CS. So I said, not really, but I said, could you speak to the importance of arts here too? Okay, and he was so funny because he looked at me and he goes, you want me to talk about the importance of art? Go? I'm like, yeah. and he did, and he had this beautiful statement about how when you study literature and and humanities and stuff, you develop empathy. And I really loved that, because also I think even in the D school in design, a lot of it is, as a designer and engineer, empathy matters. And so I think I wish I had studied more of the humanities. I think I'm empathic, but I just still think it's, I wish I had done more of that.
Well, I went to the University of Cambridge in the UK, and it has a system which I've never seen anywhere else, but it's certainly not affordable in Australia. You basically have a director of studies, and you go and you design the course you're going to do for your 3 years. And if you come at the end of that and say, I wish I'd done something, it's entirely your fault, because you could focus on art. Even in architecture, you could just do electives that were art-based or science-based or computer science-based, entirely up to you. I was very privileged to have it, and I think it would be great if we could offer that still.
I certainly wish I would have had a broader education at the university, even though we had a very flexible curriculum. Unlike what we offer here, we're still directed to, with a little bit of direction that was provided, to stay within our field of concentration. But having sort of a requirement of breadth would have certainly opened my mind earlier. What I know now and what I do now, I all acquired and accumulate. Fail fast, we talked, right? It's happening in a row. That's all acquired through research and listening and seeing the importance of admiring art and seeing the value of international education and so forth. But as it so goes, the earlier we get exposed to ideas and concepts, the better it's ingrained in our everyday thinking.
Yeah, for me, definitely architecture. Jonathan paid me $100 to say that.
Mm-hmm. Now you tell me.
Yes.
It's not too late.
Not too late. Well, they say every good structural engineer is a failed architect. So but for me, it's actually, as you know, over my academic career, sort of looking at the problems I've been tackling and the way that those problems seem to continuously scale up, right? And we start looking at some of these grand challenge problems like climate change. You know, these are challenges that really have such a deep social dimension that I feel that sometimes a little bit handicapped not having enough background in social science and some of the topics that are very relevant to understanding the social dimension to these problems and really how to bring forth solutions that are in concert with how humanity is going to adopt those solutions, things like that. And I think that's an area where we need to do more in our curriculum, particularly for civil engineers. It's really about people, right? We're trying to advance the common good, but yet we're so abstracted from that based on the way we're trained and the way we're educated. And I think that that is a real missed opportunity, and I think we should change that. So for me, it's definitely being the social domain, social science and other related areas. So.
This will be my last formal question, so I'll open it up to the floor after this last question. But is there anything in particular from the symposium that you've seen that left a lasting impression on you or opened your eyes to new research directions that you want to explore further?
Well, as I said at the beginning, this first talk this morning certainly was eye-opening for me, because we often find ourselves in the Global CO2 Initiative trying to sort of explain conflicting scenarios, right? Using CO2 for making fuels, and at the same time we want to stop using fuels and burning them. Now we know we can make much better concrete that incorporates CO2, helps clean the atmosphere, but we have learned that CO2 actually attacks it. My understanding was not as detailed as it now is, and that certainly shapes my thinking and how we need to sort of tell that overall story.
I had two things. I actually really liked the second talk. It really brought for me it just struck me the idea of really honoring the workers that were doing these projects and things, and I hadn't given it that much thought. Like my father used to study those thin shell concrete structures, and I just knew that they were thin shell concrete structures, but I'd never really thought about that, and I really appreciated that. And it also sort of reinforced my interest in the work that I presented, of not just being for the fancy shiny offices, but for the people that are cleaning them at night, or the workers, or others. And even at Stanford, we have employees that are at the poverty level or below, and so what can we do for their well-being as well? So that was one thing. And the other was I love the projects in the afternoon, the innovative and the petals, and this is the biophilic, so that'll stick with me too.
I'm an engineer, so I can't control myself. I really like all the robotic stuff I saw. I thought that was really cool. So.
I found myself thinking a lot about how effective the universities represented among the presenters are places that are world-renowned for engaging graduate students, and especially doctoral students, in leading-edge research. And one of the conversations here at Michigan that I was thinking about today is how could we bring undergraduates into that from the get-go and get rid of this idea that you do some kind of fairly generic foundational learning from a textbook, and then you get the advanced seminar, and then you get your undergraduate degree, and then in a master's degree, you're a little bit more in the research domain, but only at doctoral level are you fully in it. And how could we create what some of our colleagues call global problem-solving communities that would bring together learners at all scales, from someone like Volker, who's at the top of his game, to a high school student who's thinking that chemically re-engineering our built environment might be a passion project for them. How can we bring them together around complex problems so that we dissolve some of the barriers between undergraduate learning and advanced research?
And Mark, I saw you taking copious photos and snaps of the presentations. Was there something that was capturing your imagination?
Well, it was all catching my imagination. If I wasn't taking a snapshot, it meant that it wasn't resonating in that. For me, a completely remarkable day because of the sheer scope. I thought I knew everything, technically at least, and that was proved wrong very early in the piece. But to have the kind of cultural overlay of looking at the materiality of concrete and the vulnerability of it as the opening gambit, followed up by the extraordinary insight into it's something I think a lot about, because half my professional life has been wearing a hard hat with people doing dangerous things on site. But looking at what was happening with the thin shells and lack of the safety environment, and the fact that it's just not actually part of our thinking, I think that's probably also affected me profoundly. So no, I thought it was as all. I just don't think I've been to an event of this kind as comprehensive. So congratulations.
Yeah.
Great. At this time, are there any questions from the audience? We have about 15 minutes or so.
It's surely an unfair question because it's been such a comprehensive conference in many ways, disciplinarily, but I keep missing a little bit more, going back to the global learning environments that you were talking about. And so I love to hear you talk about concrete as a global material and these technologies are global in a ways that perhaps we haven't represented so well in the conference. Like all of the technologies that we've seen are sort of high-tech technologies of the North American, European context at the highest level of economic, intellectual, and cultural resources. So I wonder if you've encountered sort of that tension in your work. It's of course happening in the world, in other realms of technology and economy. So do you deal with that sort of elite condition within which you operate, or is that not visible yet in the same way that the worker wasn't, perhaps?
I have a little thought that came to mind is just I teach a class called Materials for Sustainable Built Environments, and I have the students do a literature review on any material they want, and a lot of international stuff comes up then, and they look at like bamboo as reinforcement for concrete, and so the class, and then they give a presentation to the whole class on these things. So they are definitely seeing much more low-tech versions of concrete, which I think is valuable. I mean, that's about as far as it gets, is that they just learn about it. Yeah, and the other thing that just comes to mind is, we talk so much about like earthquake resistance at Stanford and stuff, and then you go to some countries where there's a lot of corruption in the construction industry, and like the 3 buildings that were identical, two of them fell down in the earthquake and one stayed up, and that happened to be the contractor's apartment building or something, and so it's almost like I think that's just a huge issue that has nothing to do with the material, that has a huge impact, I think, on the materials, the image of it, and safety.
But I think that's also the opportunity to introduce new materials, right? I mean, if I understand your question correctly, you talk about some inequity issues between, say, North and South?
Not inequity necessarily, just self-awareness that this is a very local conversation. As broad as it is disciplinarily, it is a very local, in some ways, the technology aspect of it.
Very
it's very locally specific.
And I think it falls upon us to really go out and educate and disseminate that information. And I think in parts you see that happening here quite substantially through the various international education efforts, where not only a very substantial fraction of our students, and for that matter faculty, as you can hear, are foreign-born, but many of our students actually go out and do some very meaningful work, not just coursework in foreign universities, but out in the field, learning experiences that helps them better understand these questions.
I know less about concrete than anyone who presented today. But I do know about people like Kurt Gambetta who are doing or have done research precisely into what is the expertise around concrete in India, in his case, that could be generalized and shared. And one of the things that I really enjoyed at the Acadia conference a year ago was the demonstrations about Fologram, the use of augmented reality, eyewear to enable relatively untrained workers to make complex non-standard wire bending assemblies, such as might go into some of the work that Sasha was showing. And it suggested that sort of like the thesis of that book, Bright Continent, about Africa, that talks about how many countries in Africa made the leap to mobile phones and mobile payment systems well before North America. They just leapt over landlines and credit cards. I think there's a possibility that advanced technology will be deployed also to activate low-tech capacities in some surprising ways that don't require a $2 million robot.
Hi. So I have a question about, I think maybe going back to step 0. Like, what are the mechanisms in the apparatus to foster collaborative efforts between industry and researchers and academia? What are those mechanisms in the first place? Oftentimes, sort of the bigger the problem, the harder it is to start. And so I'm wondering, is there some sort of research practice speed dating game that we can all play, or like how do you find ways to come together in the first place, and are any of those kind of formalized so it makes it easier?
I've thought about this a lot, and over the years developed something called the Embedded Practice PhD. And so I'm going back to the plateau, and it's a PhD specifically for people who've been in practice long enough to realize that they need to make a difference, and they're not going to make a difference through just continuing doing what they're doing. So we work with practices that would like to see what if sort of scenarios tested where they're not actually reliant on the result being yes. So for instance, we had one PhD scholar working with Arup. So they spend most of the time actually doing the work that they're doing anyway, but it's actually PhD level research, recognized as such. And so one of them sat in Arup's office as an architect using CATIA as a parametric model at a time when Arup weren't working parametrically. So he was just literally doing the same thing as the team, and they were able to see exactly what was working and what wasn't working. And it didn't end up being a PhD in parametric design, it was a PhD on workflow and how to improve workflows between architects and engineers. So I think that's a great model because the person, Dominic Holzer, is a BIM expert, a consultant as well as a full-time academic at the University of Melbourne, has a PhD and is super fulfilled. But I think he benefited from having been, he worked at Will Alsop's office, and I think he was also at Rem Koolhaas. So he'd had a really good go at understanding how the world worked at the level of practice so that he could then find a way to do his PhD. But of course, you turn it around, it meant that the practice, i.e. in this case Arup, benefited too, because they had somebody doing something at a level that they wouldn't otherwise have been able to afford. And I think this is a model which I've had quite a few students go through this. I'm convinced it's not the only, but it's one very good way to get practice and universities to find a path of mutual benefit.
But I think, I don't know if you're affiliated with University of Michigan, but here I think
he's at SOM.
SOM, okay. But the university has a number of different units that are designed to sit at that interface between academia and industry. So here at Michigan, we have our Business Engagement Center, our BEC, we have a tech transfer office. And I think those are great resources that are there for faculty to take full advantage of. But I think it really starts, to get back to the starting point of your question, where's that spark? Where's T equals 0? And I think that really starts with the faculty member and what do they view as sort of opportunity for impact in their work. But if a faculty member has that interest, has that desire to work with industry, then here in Michigan, those organizations, our BEC, Tech Transfer, will help to curate those relationships and cultivate those relationships between the researcher, industry, working through IP terms and things like that, but really trying to position the university and its researchers to have impact in partnership with industry. But my personal feeling is that when you look at very successful academia-industry collaborations, it usually starts with individuals that are committed to having that succeed because they see that as opportunity for impact, and they're willing to make compromises. Sometimes when we see faculty that don't work well with industry is because they maybe are not willing to compromise. They want to hold their IP or things like that. So I think it really begins with that individual, and that individual taking advantage of those resources that are there to help facilitate.
Oh, yeah, I was going to add that in addition to like university-wide resources, like departments sometimes have things. So we have like a Center for Integrated Facility Engineering, and it's companies can contribute, I think it's like $20,000 or $30,000 a year, and then all of that money is pooled. It's for like virtual design and construction and 4D modeling, and they pool all that money, and then they represent their affiliates. Kind of, they come and they give out seed grants to the researchers, and then they benefit from that research, and they get to have a say in which research gets funded. So there are a lot of those affiliate programs, I think, that different universities have as well. But then sometimes it's also just that one-off collaboration, like we've actually had with SOM, someone from San Francisco that works with one of my colleagues, and they tried out a new connection that didn't have to go through too much of those bigger channels, but it was just that they had a good collaboration.
Sure, but at the end of the day, no matter how it starts, certainly Jerry spoke about how this is best done, It's all about building and maintaining personal relationships, right? To have that trust so you can give and take. I think most universities are less good and set up for sort of one-offs, a small contract here, like almost like work for hire, rather than long-term stability that you know to take inspiration from practical needs to translate that into fundamental research questions on which we are good at. At the same time, we are then educating students on a very practical path, pretty much giving the companies multiple years to interview those students. I mean, we've seen that successfully happening in so many different examples that for me really emphasize that it's really a human-human interaction that has to be the key to this.
We have time for one more brief question, if anyone. No, you. Great, perfect.
So kind of piggybacking off of that, the discussion topic was from lab to site, but then in this discussion here, you guys also kind of touched on the kind of like slowness of innovation in our industries and kind of like the policy that influences that or hinders that, take it as you will. I'm interested to learn what you guys have found out in relation to either more design professionals moving towards policy because we are more aware of the social and economic and all these other factors going into the built environment, or the kind of what we spoke about in an earlier discussion as well, the kind of like national organizations playing a role to educate policymakers.
I think that's a hugely important topic. And one of the most relevant aspects in that is how we communicate. Right? We're so good in talking amongst ourselves, and if somebody hears us speak who's not in our profession, they hear words that they might understand individually, but they put no meaning to the sentence. Right? So having the ability to translate our technical knowledge into information that actually helps policymakers is something that doesn't always work so well. And I think we work, of course, with our students to help change that, but we see that all the time.
No, go ahead.
We've just won some Australian Research Council funding to set up a digital pin-up space. And so we're taking the challenge on the urban futures, which is how do we get experts to talk to each other in a way that they understand? And we think that a visual environment where you can all have your work up at once is one thing. The next challenge is how do you get expertise recognized as being of value and of consequence by those end users and key stakeholders? So how do you get them to appreciate that expertise is actually of value? Because in Australia, there's a little bit of the opposite going on. There's a lot of suspicion because we don't talk a language that's understood. And then crucially, how do we get those people who are at the end of the end user, how do we get them to be able to speak and be listened to? And so I think if we can get this, that is the major challenge at the moment, I think probably everywhere. And you have to watch the space, but we've set this environment up. It'll be ready in the middle of next year to actually specifically do just that with policymakers in the space, which in our case is local government officials, being able to pick up the nuances from both the experts and the people most affected by the decisions.
I think also, I was going to say, just in like structural engineering, at least of the local professional organizations, like where I am at Structural Engineers Association of Northern California, they have committees and you get involved there, and they actually interact quite well with like the city government, and they pass policies or ordinances. I'm not sure what they are, but like there's a big issue in San Francisco with soft stories, so they needed to be retrofit. So it was a lot of advocacy on the part of the engineers, and again, like having to communicate well. But there are a lot of opportunities, I think, through those local professional organizations.
Yeah, and I was just going to maybe expand scope on the question because you were talking more specifically about policy. But we talked before about innovation maybe not being fast enough. And my personal opinion, part of that maybe is because our existing business models may not be working. They may be broken. And in the civil engineering profession, we're already seeing a profession that's dramatically going through a transformation, not always good, and part of it ties to our current business model. So I think there's a lot more growing interest in changing that business model and changing the opportunity landscape based on the business model. So it's not just policy, but if the economy is not reacting and allowing for innovation to see the light of day, then maybe we need to change the way that economy works. So one place we're seeing that certainly is in the smart city space, right? Talked before about smart cities, what does it mean? But one of the biggest segments of that smart city arena is new financing vehicles that are going to tie to infrastructure. For example, in civil engineering, you often hear about deteriorating infrastructure, partly because of the way we pay for it. That business model doesn't work. So thinking about new ways to bring investment in, invoke the private sector to contribute to this common cause of advancing robust, resilient infrastructure. I think there's an opportunity for us professionally really to see a future world that's going to be better, more innovative, accelerate the adoption, but it'll come through new business models that we'll adopt. So.
Unfortunately, we're out of time, so please join me in thanking these great guests for the wonderful answers and responses.